All right, I'm not going to take up any more of your time waiting. Let's go ahead and get started. First off, I would like to thank everyone for taking some time out of their day to join us on this fine Friday morning. Let me quickly introduce myself. My name is Colin McLeod. I'm a digital marketing specialist here at ICP USA. Been working here for about a year and a half, and I think I'm just starting to get the hang of things. So today, we're going to be talking about industrial IoT, or the industrial Internet of Things. Over the last couple of months, I've been building up to this talk, so I'm very excited to present it. Last month, we talked about remote monitoring and maintenance. The month before that, we talked about OEE, a subject that is going to be highly relevant to this discussion. So if you were not able to attend that talk, I recommend you make some time to watch it after this presentation. It's available on our website, our YouTube channel, and if you email sales@icp-usa.com, I will be more than happy to send you a link. The month before that, we talked about our WISE IoT controllers, and at our Lunch and Learn just a few weeks ago, we talked about the PM3000 series smart power meters, both of which can be easily integrated into IoT platforms. So if you're interested in any of this background info, please feel free to email us at any time. All of our contact info is going to be at the end. Okay, let's go over the agenda for today. First, we're going to talk about what IoT is and what it isn't. I want to leave you with a practical definition of IoT and IIoT and take a little time to differentiate it from the SCADA systems you may be familiar with. Then I'm going to talk about how IIoT systems are structured. We'll look at some of our IoT specific modules and then talk about IoT Star, our very own IoT platform. Finally, we'll look at some case studies, wrap things up, and move on to our Q&A session. I have Robert with me today. He's one of our, I think I have Steve and Robert, two of our engineers with us here today. And they are going to be able to answer your questions during our Q&A session at the end. So I will ask that you do hold your questions until the end, but if you think of one during the presentation, you can type it into the Q&A box at the bottom of your screen. Do be sure to enter it into the Q&A box and not the chat box, because we will not be checking the chat box. You can also raise your hand through Zoom, and we will unmute you so you can ask your question on mic. But again, I do ask that you wait until our Q&A session at the end. And after the Q&A, we will then announce the winners of this month's raffle. So let's move on. So if this is your first time joining us, a little bit about ICP-USA. ICP-DAS, that's our parent, or it's our home office, was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICP-DAS USA, that's us, was launched in 2001 to support the North and South American markets. We're located in Lomita, California. We have over 200 R&D engineers who work closely with them to add new features to our products, develop new products, and to support our customers. Most of our products are RoHS compliant, meaning they're lead-free. We have our ISO 9001 certification, which ensures we meet product statutory and regulatory requirements. So the first question is, what is IoT? So I'm going to assume that all of you are familiar with IoT as a marketing term or a buzzword, but I'd like to leave you here with a more functional definition. The problem with this is that IoT is more of a systems design philosophy than a set of specific components or technologies. When I think of IoT, I think of wireless communication and cloud storage. So the idea is that you have a bunch of machines or sensors that are all communicating with each other wirelessly, and all the feedback you get is sent to an offsite server that you rent from Amazon. It's all very expensive and opaque, and as anyone who's tried to set up a smart lighting system at home will know, it doesn't work half the time. Fortunately, all of those things are just technologies or techniques that are an optional part of any IoT system. The point of IoT is not to make things more complicated and opaque, but more simple and transparent. Furthermore, you don't need a whole lot of special equipment to take advantage of IoT. The Internet of Things is any network of machines, sensors, controllers, and etc. that communicate with a server or servers without the need for a bunch of human interaction. So, the definition of IoT, or maybe the goal of IoT more accurately, is a platform where all the data you need are in one place and all the right people have access to that platform. The platform doesn't even have to be internet accessible, it can all be internal, but accessibility from anywhere is one of the features of most IoT platforms, including our own IoT Star, which we'll talk about a little bit later. So, second question, what is IIoT? And if you're watching this, you're probably a manufacturer, you work in a lab, chemical plant, or you're managing a big office building or campus. In any of these scenarios, you probably already have a network of embedded sensors and controllers that gather data and run processes. This system might be managed wirelessly over Ethernet or serial communication, but none of this needs to be changed for you to integrate that system into an IIoT system. It's possible to use gateways, converters, and routers to get the network you already have to communicate with your new IoT platform. Thus, integrating an older network with a new platform that captures data in real time can also store a large amount of historical data, which can then be accessed by the right users. If it's a cloud system, you can access it from anywhere. Industrial IoT then is simply the application of IoT principles and technologies to industrial processes. Third question that I have when I think about IoT is what makes IoT different from SCADA? And the main difference here is scale and time frame. So, a typical SCADA system is concerned directly with controlling manufacturing processes and acquiring data directly related to the production process. You should think of an IIoT platform as operating on the layer above SCADA. IIoT is less concerned with the I'm sorry. IIoT is less concerned with the control of industrial processes and more concerned with integrating a wide array of sensors and equipment, collecting all of their data, and presenting that data in a human readable manner that you can then access over your server. So, what are the benefits of industrial IoT? Like I said, it's operating on the layer above SCADA to collect and present data. The goal of IIoT is to connect every machine in your factory to one platform. The benefit is to go above and beyond things like start stop status and production count. These platforms provide enough storage space and processing power to collect metadata about your production processes, and that's where the real cost savings come in. Remember, a few months ago, we talked about OEE, or overall equipment effectiveness, which is a formula that helps you find the bottlenecks in your production process so you can smooth out all of those small inefficiencies that are dragging the entire factory down. With an IIoT platform, you can easily connect the kind of sensors you need to monitor equipment performance and perform meta analyses of your process that will lead to increased efficiency. Further, IIoT puts your primary production data and this kind of metadata into the same platform where you can access all of that data going back months and months. You can then create graphs that show you when and how things are slowing down. Another benefit of IIoT is that it makes all this data available and readable to anyone who needs it. IoT makes horizontal integration between different organizations or departments within the same organization much easier by providing a common medium that everyone can use to understand the data. So IIoT makes it possible to integrate production process feedback with environmental data, power usage, machine status, operational data, and more. All the feedback that you can imagine in one easy to use system. So, what does an IIoT system look like? And what you're looking at now is from one of the use cases that we're going to talk about a little bit later in the next couple slides. But I think it gives a good impression or an overview of what an IIoT network might look like. This comes from the application of one of our OPC servers, the UA5231. This model is slightly out of date now, but I think it still provides a good example of how you can incorporate different networks and communication methods into the IoT platform. This model comes with 4 serial ports to connect a wide variety of devices, and it uses its Ethernet interface to push data to Ethernet controllers as well as to your cloud. It's also an MQTT client, so it integrates your networks, your machine side or your factory side networks with IoT platforms like Microsoft Azure, IBM Bluemix, and Amazon Web Services. So you can see it's actually fairly simple. You just have a bunch of different types of devices and methods of communication that are mediated through the IoT server, which is then connected to your IoT. In this case, it's a cloud platform. So, very quickly, I would like to talk about some of the different kind of devices that you can use to connect to an IoT platform. I want to quickly highlight some of our IoT specific products. So, first, like I mentioned in the last slide, we have the UA5231, which is the aforementioned OPC server and MQTT client. The UA5231 is a data acquisition controller and communication server specifically built for IIoT applications. The UA5231's built-in OPC UA server and MQTT client service support a variety of common industrial communication protocols. Its RISC-based CPU architecture gives the module a small size and low power consumption, making it as useful in the office as it is on the factory floor. This module provides a variety of communication interfaces such as gigabit Ethernet, USB, RS-232, and RS-485. Next, I want to touch on 2 families of modules that we've talked a lot about recently, so I'm going to try to be brief. These are the YS5231 and the PMC5141. The YS5231 is simple to use and integrates easily with IO modules and sensors on the field side and supports various IoT protocols, integrates easily with SCADA, MIS, MES, and IT network management systems on your network side. It offers reliable real-time IO logic control and data logger functions. It has a user-friendly website interface that allows for if-then-else control logic programming. These are very easy to use. The onboard logic engine eliminates the need for custom hard code programming. The WISE 5231 is very flexible in terms of its I/O connectivity. You can connect Decon I/O modules, Modbus RTU modules, Modbus TCP modules, and the optional expansion boards can give you direct I/O functional right on the module itself. So in short, WISE 5231 does everything that the UA server does, but with a little added processing power and extra I/O functions. And then there are our PMC series smart power meter concentrators. So at ICP-S, we offer a wide array of power meters to be used with all kinds of machines, single, 3-phase, low, medium, and high voltage. PMC 5141 is what we call a power meter concentrator, which is a data logging module specifically designed to work with our smart power meters. It allows you to connect to our smart power meters over RS-485 to read power data of the devices, then save the power data, send the data to a backend FTP server, SCADA, or IoT platform for further data integration and analysis. PMC 5141 also provides power demand management and alarm notification functions. It has a built-in web server, which allows users to connect via browser to view power data, set up parameters for the controllers, or view real-time and historical power data of your connected devices. Uh, Both these modules and the family of products that accompany them, because they do come, these are just single modules out of pretty large families that have a lot of options. And if you want to see a selection table or get more information about those, please feel free to email us. Our contact info will be at the end. Yeah, you can see how these modules and the family of products that accompany them are easy to use, flexible data logging and network management tools, all built from the ground up with IoT in mind. So now I want to talk about IoT Star. And I'm very excited to talk about this. This is our very own IoT platform. So, IoT Star can be installed on a general PC platform as a private cloud management system for our WISE, PMC, PMD controllers, the ones I just mentioned, or installed on the virtual machine platform of Microsoft Azure, IBM Bluemix, or Amazon Web Services, etc. Any of those MQTT IoT platforms and you install it on the virtual machine as a public cloud management system for the controllers that I mentioned. In addition to providing remote maintenance and firmware updates for the connected modules, IoT Star can also collect I/O channel data and power data from I/O modules or sensors and power meters connected to our IIoT controllers, and then import these data into the database to provide real-time status monitoring on your automation control and monitoring system. So with IoT Star, users can access system settings in just a few clicks using a web page interface and perform remote access for status monitoring, system settings, firmware updates. And users can also access sensor data operations for each IoT controller. Through its SQL database functions, IoT Star can quickly be integrated with cloud platforms and data analysis tools like Microsoft Power BI, Google Data Studio, etc. Or you can integrate it with SCADA system. And all of this helps you quickly build up your cloud IoT system. Okay, moving on to some application examples. This is the diagram that I showed you before for the UA5231. The UA5231 is our IIoT server slash controller. Um, it can help to fulfill the integration of a wide range of physical or virtualized functionalities. The UA5231 is a versatile intermediary control system. At the lower end, it can integrate sensors, on site devices, and IoT applications. And at the upper end, it can integrate project management, manufacturing, and other management applications. By using this controller, factories and enterprises can create web based vertical integration of both upstream and downstream systems, integrate on site data in the backend system for further analysis, and horizontally connect each subsystem. Now, I want to talk a little bit about our YS5231 controller, which provides a powerful and flexible integration with I/O modules and sensors on the field side. It supports various IoT protocols for seamless integration with your SCADA, MES, MIS, IT, and IoT management systems to transfer real time IO information from the front end modules or sensors to your back end management systems. It also features reliable real time IO logic control and data logger operations. All of these features make the YS5231 the perfect concentrator of sensors and IO modules for your IoT system. And that about wraps it up for this month. I hope that you've learned something about IIoT and its applications in manufacturing. Again, the goal of IoT platforms is to give you as wide a platform as possible to collect and represent all kinds of data with the intent of horizontally integrating the different departments and manufacturing processes. But that is about all that I have for you on IoT today. So next, we're going to move on to our Q&A session, and then following that, we're going to announce the winner of this month's raffle. So first, I'm going to look and see if we have any questions in the Q&A box. Please feel free to type them now, or just use the Zoom interface to raise your hand, and we'll unmute you so you can speak to us on mic. Again, my colleague Robert is here. Yes, we have Robert and Steve are here. They are some of our applications engineers and can answer your more technical questions. So let's go ahead and open up the floor.